Hi and welcome to the Simultaneous prediction for the Edexcel GCSE Maths Paper 3 Foundation tier. Enjoy! Hi and welcome to this prediction from Maths for the very last paper. So this is going to be filmed before any of the papers, so please bear that in mind when you watch this. The papers are very condensed, and so it's very difficult to set new videos out. But this paper is still based on all the previous exam paper questions that have come before, including the June and November ones in previous years. And we look at what comes up loads and what has long overdue coming up. Don't also forget you can do this online by clicking here, and it's completely for free, and you can sign up for free and save your scores so you can track your progress with this. On our site it's also the topic busters, which are very focused on specific topics, and there's all the Maths GCSE topics there, so you can practice a specific topic rather than the more generalised. You can also do the revisionator, which will just blast you with random questions. It normally takes about 10 to 15 minutes to complete. So if you've got less time or you want to do something regularly every night, then that's a really good idea. Don't also forget that the online version is random numbers. So the methods and questions will be the same as this video, but the answers will be different, allowing you to do multiple times. If you like this video, please click like. And if you want to see more from us, please click subscribe. Also, just bear in mind that this is a revision tool. Please do all of your normal revision as well. I hope you enjoy this video. So for this question, we're asked to find the percentage of the shape that's shaded. So there are 4 sections in total and 2 of them are shaded. So as a fraction, that would be 2 over 4. Well, we can halve top and bottom, so it's a half. And you can see there that half of that's shaded. So what is half as a percentage? Well, a whole as a percentage is 100%. So a half as a percentage is 50%. And if you didn't know that, you need to just practice knowing the main percentages. A tenth is 10%, a hundredth is 1%, and a quarter is 25%. Okay, the next question says what fraction is shaded. So we need to know 2 things. First of all, how many squares are shaded. So 1, 2, 3. So it'd be 3 over the total amount of squares. So there's 1, 2, 3, 4, 5, 6, 7, 8 squares. So the fraction is 3 over 8. For the next question, it says shade in a fifth of this shape. Well, there's 10 squares altogether, and we want to shade a fifth. So we need to find a fifth of 10. In other words, what's a fifth times 10? When you times something by a fraction, just divide it by the bottom of the fraction. So another way of writing that is 10 divided by 5, which is 2. A different way of thinking about this question is if you cut this shape up into 5 equal sections, those sections, the green sections, become a fifth. So if we want to shade 1/5, we just want to shade in one of those sections. And actually that's the amount of squares that our calculation just worked out. So it should be 2 squares. Now, it doesn't have to be the 2 squares that I've shaded. As long as you've shaded in 2 squares, then you've answered the question. And the last question says, write down the fractions there that are equivalent to a quarter. Well, a nice easy way of starting this question off is just write down things that are equivalent to a quarter. So what I'm going to do is I'm going to times top and bottom of this fraction by 2. So 2 over 8. So I've times them by 2. Then I'm going to times them by 3. So it would be 3 over 12. Then I'm going to times them both by 4, and I'm just looking at this original fraction here. I'm going to times them both by 4, so it would be 4 over 16. And times them both by 5, 5 over 20. Now all those fractions are equivalent, which means the same as a quarter. So let's have a look at our list. Well, we've got 2 over 8 there, so it's that one. And we've got 5 over 20 there. So my answer is going to be fraction B and fraction C. So it asks for an even cube number.
So the cube numbers are 1 cubed is 1 times 1 times 1, which is 1. The problem is that that is an odd number, so let's try 2 cubed. Now 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 8 is an even cube number. Now you could have also had 64, which is 4 cubed. 6 cubed is above 100, so that would not count. So 8 or 64 are the correct answers.
Okay, so when simplifying, it's really important to understand what like terms are. This is an x term, and this is also an x term. This is a y term, and this is a y term. So we're going to add the x terms first, so 13x plus 7x is 20x. And then we're going to add the y terms, so 3y plus 2y is 5y. Now it can be tempting to try and add these together, but these are unlike terms, they're not like terms, so we can't add them together. You can multiply them, so if we times them together it would be 100xy, but when we add them we can't add them. That is our answer. Okay, so we're asked to round to 3 significant figures. So what I'd try and do first is write the number down. Now, with significant figures, we start counting at the start of the number. We don't start counting at the decimal point. So I'm going to start counting here. And I'm going to count 1, 2, 3, and I'm going to draw a line down. Now, all the numbers to the right of that line are going to reset to 0. But before they do, we need to look at this number, and this is called our decider number. If that number that I've circled in blue is 5 or more, it means the 7 goes up to 8. If it's less than 5, the 7 stays the same. Now because it is 5, that 7 will go to an 8. Now be careful here, the numbers to the right don't disappear, and some students, when they've done decimal places, they think they just go away. With significant figures, you have to remember that they turn to 0. Now they do the same with decimal places, it's just because they're after the decimal point, we don't need them anymore. But these 3 zeros here are what we call placeholders. So, for instance, if you're asked to estimate the size of a crowd, and there was 207,518 people, you wouldn't say that that was roughly 208 people. You would say that's roughly 208,000 people. With any sequence, the first thing to check is whether it goes up by the same amount. Well, looking at this goes up by 1, this goes up by 3, so it's not going up by the same amount. This goes up by 4, this goes up by 7. But something you might notice is this goes up by 7, and yet there's a 7 here. This one goes up by 4, and there's a 4 here. This goes up by 3, and there's a 3 here. This is what we call the Fibonacci sequence. So the Fibonacci sequence just starts off with 2 numbers, and then we add the previous 2 terms to get to the next term. So we'll add these 2 together to get to the next one. Then we add these 2 together to get to the next one. So to find the next one, we need to add the 11 and the 18 together. 18 plus 11 is going to be 29. So the next term is going to be the 29th term. Let's just check that's the 6th term. 1, 2, 3, 4, 5. So yes, that would be the 6th term, would be 29. Then we need to add the 18 and the 29 together. And when the numbers get big, if it's not on the calculator paper, you can just add them like this. So 9 plus 8 is 17, and that's going to be 3 plus 1, which is 4. So it's going to be 47. So the 7th term is going to be 47. So always just check that the sequence isn't a Fibonacci sequence before you start to panic and think, what is this sequence? Always check for a Fibonacci sequence. It was just that the previous 2 terms are added together to make the next term. Okay, so in this question we see that a square has an area of 121 centimeters squared and we're asked for the perimeter of the square. So the first thing I would do is do a quick little diagram of this square, and we know that the area is 121 centimeters squared. Okay, so I know it's a square, so therefore the width, or the base, and the height will be exactly the same. Okay, and I know to find area, I do this one times this one. So I know that x times x, or x squared, equals 121. And if I put my lines in, then I can square root both sides, and so x is 11. So I know that 11 times 11 is 121. Now the temptation is to think, right, I've got the answer 11, but it's asked for the perimeter of the square. So I know perimeter is the distance around the square, and each side is 11. So it's 11 plus 11 plus 11 plus 11, or 11 times 4, which is the perimeter, which is 44. So the answer is 44 centimeters. So when conducting a survey, you've got to make sure that you are looking into a few areas. The first area is to make sure that your questionnaire is fair, that it's not swaying the person's opinion with leading questions. The second thing you need to be careful of is that your sample is what we call representative. It means that everyone from all different areas have a view. So for instance, if you were looking at investigating the school canteen and you only picked people who used the school canteen, then it's probably going to be swayed towards how wonderful the canteen is, rather than the people who don't go to the canteen, who probably don't go because they don't like the canteen or because they bring packed lunch. The other thing that you need to look for, and there's quite a long list, but the other main thing you need to look for is that your sample is big enough. If it's too small, then it can't possibly be representative. So when it says select 5 names, 5 people is not enough for a proper survey. So my answer to this is step 3, and I would say sample is too small. Okay, so the numbers in this question seem a bit daunting, but the process is always the same with this type of question in ratios. The first thing you've got to realise is, are you given a total amount, or are you given an amount of food or amount of drink? Where it says in total, they spend that amount, so it's a total amount. So step 1 is to work out how many parts you have altogether. So for food it's 39, and for drink it's 4. And this will be a calculator question, so why not use the calculator even though we can do it in our head. 43 parts. So we've got 43 parts. The next stage of this is to work out what one part is worth. So one part is worth how much? Well, you get the amount and you divide it by the number of parts. You're splitting the amount of money between 43 parts. So 11911 divided by 43. And I get £277. So each one part is worth £277. Now let's read the question. Find how much money is spent on drink. Well, drink is this one here. And the order which they are in the question, food, drink, is the order which the ratios are. So food, then drink here. So there are 4 parts. So we're just going to write drink. So if each one part's worth 277, we're just going to do 4 lots of that. And I might as well do it in the calculator. Times by 4. And that's going to be 1108. So 1108. Instead of going straight to percentages for this question, I would first of all get it as a fraction. So it says there's 15 students who are female and 31 altogether. So the fraction is going to be 15 over 31. And to simply convert between fractions and percentages, all you need to do is times by 100. And percent means per 100, so it's always going to be times by 100, and that'll always get you a percentage. So I'm going to get my calculator out. Now I can write that as a fraction, or I could do 15 divided by 31. It gives you the same answer. So 15 over 31 times by 100. And it gives me a fraction, so I'm going to press S to D. And it's 48.3870, blah, blah, blah. And it says give it to the nearest percent. So that's a 3, so it's not going to move that 8 up to a 9. So it's just 48%. Okay, so we're asked to find the midpoint, which is just kind of the halfway point, and we're given 2 coordinates at the start and end of the line segment. And a really easy way of doing this is you're just finding out the average of the x coordinates and the average of the y coordinates. So to find an average, we're going to do the x coordinates first. You add together the 2 coordinates, the 2 x coordinates, and divide by 2, because there's 2 numbers. So 2 plus minus 1, well, 2 take away 1, because the minus will win against plus and a minus. So 2 take away 1 is 1, and divide by 2 is just going to be 0.5, or just a half. The y's, so here we've got minus 5 plus 2 over 2. Minus 5 plus 2 is minus 3 over 2, which is going to be minus 1.5. So the coordinates are 0.5 minus 1.5. And if you think about it, half is halfway between 2 and minus 1, so that makes sense. And minus 1.5 is halfway between minus 5 and 2. So we're told 1 kilogram of cheese costs £7.70. How much would 600 grams cost? Well, first of all, I'm going to have weight, mass, and price. And I'm just going to sort of split them down the middle. So the weight, well, 1 kilogram is not going to help us because this one's in grams. So I'm going to convert that to grams. So it's 1,000 grams. And I'm going to convert this into pence. So 770 pence. Okay, so I need to get to 600 grams. And so first of all, if I've got a calculator, I can do this a lot easier. But without a calculator, let's try. Well, I can first of all divide this by 10 to get it so that it's 100. So that's 100 grams. And that would be 77. And then what I can do is I can times these by 6 to get 600. Okay, so if you've got a calculator you can just type it in, but let's assume that you don't for this question. So we've got 77 times 6. 6 times 7 is 42, add a 0, 6 times 7 is 42, add them together. Probably don't need to do this, but anyway, I'll do it anyway. 264. So it's 462 pence, but in pounds it would be £4.62. Last thing, just check it makes sense. Well, we've got just over half, so therefore the price is just over half. So it looks good to me. Okay, so we've got a scatter graph question, and the first question asks us just to plot the information from the table into the scatter graph. So we've got ice cream sales at the top and temperature at the bottom, which is not kind of the same way around as on the graph, so we've just got to be careful. So the ice cream sales are 46, which is here on the scale, and the temperature is 31, which is here on the scale. And just check that you're looking at the scale correctly. So we're looking about, let's have a look, about here. Okay, next one, ice cream sales 40, which is here on the scale, and temperature 34, which is here. So just got to be careful, and it's about there. So those are the 2 plots that we want to take. Next question says, on another day had an average temperature of 45 degrees. Use the scatter graph to estimate the sales of the day. Now, you need to get used to just drawing a line of best fit to any scatter graph that you come across. You will have to do it, okay? So just do it. Just, even if it doesn't ask you to, just draw a line of best fit. Now, a line of best fit is just a line that follows all the data like that. You should have roughly the same amount of data top and bottom, but it doesn't matter if it's not perfect. Okay, so let's have a look. So we've got average temperature of 45 degrees. So we're going to draw a line up from 45 degrees, which is about there. And we're going to draw, oh, the line didn't come up. So let's draw that line there. It's refusing to come up for some reason. Let's try another one. There we go. Let's try another line. Okay, let's do it the old-fashioned way. Okay, and then we draw a line across from where it's the line of best fit. Now, to me, that looks like about 55. But if you had the same question and you came up with a different answer of 54 or 58, it still can be correct because you might have drawn a slightly different line of best fit. Okay, so don't worry if you sit down next to someone, do the same question and get a slightly different answer. Just draw the lines, straight lines, unlike mine, onto your diagram to show the examiner that you worked it out. So we've got 55 sales we're predicting. Now, what do we notice about this? Well, look at where all the data is. All the data is here, and yet we're estimating outside the range of the data. Okay, it's called extrapolation, where you do that. So the problem with that, if you imagine we do a graph of height against age, so we have age at the bottom and height up the side, then when you're very young, you grow quite quickly. And if someone extrapolated your data and said, oh, okay, well, that growth is going to continue, when you're 80 years old, you're going to be 20 foot high. Well, that doesn't make much sense. It's because we're quite confident with down here because we've got data for that, but we're not very confident with this bit here. We don't know whether the trend continues. Now, with ice cream sales, if it's ridiculously hot, no one's going to leave their house. They're all going to be sitting inside with their air conditioning or sitting in their car with their air conditioning. So we know it probably won't continue. So if you just say that the estimate is outside the range of the data, and if you want to really impress the examiner, then you can use the word extrapolated. It's been extrapolated. Okay, factorize means put it into brackets. So looking at the first one, there's a t I can divide out of both of them, so I put t on the outside of the bracket, but there's no number because 7 and 5 don't have anything that goes into both of them. So I think, what do I times t by to get to 7t squared? Well, it's going to be 7t. And what do I times t by to get to 5t? Well, it's just going to be 5. You can check your answer by expanding the bracket to check it makes 7t squared plus 5t, which it does. Next one, w is only in the first term, so I can't divide out the w, but there's a number I can divide out of both of those. Now, I could pick 2, but actually 4 is a better number because it says factorize fully, which means I need to take out or divide out the 4 rather than just the 2. So 4 on the outside. What do I times 4 by to get to 12w? Well, 3w. And what do I times 4 by to get to minus 8? It's going to be minus 2. And again, I can expand that to check it. Right, the last one, there's a number and a letter. So I'm thinking the number of 16 and 24 would be 8, and the letter would be A. Okay, so there's two things that we're dividing out this time. So I'm going to have 8a on the outside. So I figure out, what do I times 8 by to get to 24? Well, that's 3. And what do I times a by to get to a squared? Well, that's going to be a. What do I times 8 by to get to 16? 2. And what do I times 2 by to get to 16a? So it's just going to leave it because the a is on the outside of the bracket. So a to a times 2 is 16a, so I don't need an a there. First thing we need to realise with this question is, which transformation is it? Well, you have to go through the 4 transformations. The first one I think of is, has it rotated? Has it spun around? No, it hasn't. Second one, is there a mirror image of it? No, they both look the same, so it's not been reflected. Has it grown or shrunk at all? No, so it's not an enlargement. So that leaves transformation. Translation. Translation. Now translation just means we've moved it, and that's perfect because we have just moved A to B. Now the second thing to realise is we are starting at shape A and we're going to shape B. Now with translations, to describe them, pick the same point on both shapes. I always pick the top left if it's available. Then what we want to do is work out how far left or right I have to go from A to get in line with B. And I do this with jumps, and the reason we do this with jumps is I never get the wrong answer when I do jumps. So 1, 2, I need to go 2 left. So 2 left. And let's have a think, how much up do we have to go? So 1 jump, 2, 3, 4. So 4 up. Now the way of showing translations is by using vectors, and it sounds fancy, but it's just putting this information here between a bracket. The number at the top of the bracket is how far right it's gone, and the number at the bottom is how far up it's gone. Well, let's do the number at the bottom first. So translation by, there's different words you could use there, and the number at the bottom, well, it's gone 4 up, so it's just a 4 there. Now here's a problem. This is how far right it's gone, but it's gone 2 left. Well, we just simply put -2 right. Now be careful, don't ever put a fraction line between the -2 and 4. It's not a fraction, okay? So don't ever put the fraction line in. These questions are just based on a few rules of indices. The first rule says that if you've got two powers with the same base, which these two do because they're both A, you add the powers. Now if you think about it, A squared is A times A to the power of 6 is A times A times A times A times A times A. So in total we're timesing A by itself 8 times. So it's 8A to the power of 8. The next rule says if you've got a power inside the bracket and outside the bracket, you times them together. So it's m to the power of 3 times 6, which is m to the power of 18. Now this last one's a little bit more complicated, and I'm going to write it out so I've got a bit of a larger one to play with. Okay, first thing I focus on is the number. Now 55 over 11, so I know that 55 divided by 11 is going to be 5. 55 divided by 11, that's all we've got to do. And the reason we can do that is there's only one term at the top and one term at the bottom. Term is defined by, whether there's a plus or a minus, and there's no pluses or minuses here. Okay, so next one, we've got the r's that we want to divide. So we've got r at the top and an r at the bottom. Now this r at the top is technically r to the power of 1. Now when we do r to the power of 1 divided by r to the power of 8, which I'm going to write out down here so I can show you, you take away the powers. So when you times them, you add the powers. When you divide, you take away the powers. So that's r to the power of -7. Okay, now we're left with the s's. And it's the same thing with the s's. This time we're doing s to the power of 15 divided by s to the power of 8. So it's going to be s to the power of 15 take away 8, which is 7. So my answer would be 5 r to the power of -7 s to the power of 7. Okay, to convert from standard form, you just write the number down, and this here, the power, will tell you where to go. So if the power is positive, then you go to the right. If it's negative, then you jump to the left. Now since it's negative, we're going to jump to the left, and it's -6, so we're going to jump 6 spaces. So 1, 2, 3, 4, 5, and 6. So the decimal point will now be here, and you fill in all of the jumps with zeros. So one of the jumps is used by the 8, but all the other ones we fill in with zeros. And whenever you've got just a decimal point, you need to have something before it, so we put a 0 before it. So the answer will be 0.00000084. That would be the answer. So let's just count. There's 5 zeros and 5 zeros. Okay, to convert to standard form, you write out the number and you try and put a decimal place in to make the number between 1 and 10, but not including 10. So if I put it in here, that would be 72, so that would not be right. So I need to put it in here. Then you count how many times you had to move the decimal point to get it there. So the decimal point started at the end of the number, and we had to move it 1, 2, 3, 4, 5, 6. Okay, so the rule is that the number has to be between 1 and 10, which this one is. Now, if you had a big number, then the power of 10 will be positive. Now here we did have a big number, so it's going to be positive 6. On the previous one, we had a small number, 0.00084. I don't know if I said the amount of noughts that were there, and you can see that the power in the question was negative. So negative power of 10 is really small number, positive power of 10, really big number. This does turn up on the calculator paper as well. So if it does, you can actually just type in question A into your calculator and just write down the number it gives you. Now some calculators are smart and do things in standard form, so you might need to do it this method anyway. The triangle we need to remember for this question is density equals mass over volume. Now you could have kind of worked it out with the question because it says grams, which is mass, per centimeters cubed, which is volume. So per means over, so it would be mass over volume. So we need to work out the mass. Well, at the moment we have the density, so we've got that, but we haven't got the volume. So the first thing I need to do is work out the volume of the prism. So to work out the volume of any prism, it's the cross-section area times the length. And some people call the length something else, but the length is basically how 3D the prism is. So the length is this one here, and the cross-sectional area is the area of this triangle here. So it's the area of the triangle. We've got the base, which is 4, and the height, which is 9. So it's half times base times height, and then we're going to times it by the length, which is 10. So what have we got? The base, which is 4, so it's half times 4 times the height, which is 9 times 10. Now, the reason I know the height is 9 is that it hits the base at right angles, and that's really important. The base and the height must be at right angles. And don't forget to halve it. Now, what I can do here is something quite sneaky. What I can do is I do half times the 4 to get 2, and that saves me timesing some big numbers together just to halve it. So 2 times 9, which is 18, times 10, which is going to be 180, or you can just type it into the calculator if it's on the calculator paper. Okay, so that is in centimeters cubed, because every unit is in centimeters, and make sure you check that. So the volume is 180, so to work out the mass, if I cover up the mass in the diagram, so I cover that up, it says to work out the mass I do density times volume. So it gives me the density in the question, which is 5.5, and I'm going to times that by 180. So if I have a calculator, I can just type that in. Otherwise I could do 5 times 180, well I can do 10 times 180, which is 1800, then halve it, which is going to be 900, and then half times 180, which is 90. So that's 990. So the answer is 990 grams. Alright, so we're asked to draw a frequency polygon, and The only error you're going to make with this type of question is figuring out what a frequency polygon is. Now, a frequency polygon is where you put little crosses at the points, and the points lie at the group's midpoint. So we've got our first group 0 to 10, so the midpoint would be 5. Next one is 10 to 20, so that's going to be 15. Then 25, then 35, then 45. So the first one's going to be at 5, and it's going to be 6 high. It's going to be like that. Next one's 15, 22. So 22 would be about there. 25, 59. So 59 would be right up here. 25. 35, 15. A little bit lower than that, but that's fine. 45, 4. Now we're only halfway done, and my points aren't exact because the screen I'm using isn't the most precise, but it's good enough. We're only halfway done because what we need to do is join these up with straight lines, so no curves needed. And when you join them up with straight lines, do not ever join up the last 2 points. You're not actually trying to make a polygon, okay? So don't ever, when you join them up, whatever, right? Don't ever draw this line here, okay? That's not a good thing to do, so make sure you don't do that. Okay, and that's it. So midpoints, crosses, and then join them up with straight lines if you're asked for a frequency polygon. Alright, so it says that the town council is saying that over a quarter of the stores get over 30 customers. So we're going to see whether that's right. So over 30 customers would be these two groups here, so 30 to 40 and 40 to 50. So that is 19 altogether. So that's 19 out of, and let's add all the rest up, so 6 plus 22 plus 59 plus 15 plus 4, out of 106. It didn't say it in the question. So it's 19 out of 106, which as a decimal, 19 over 106 be 0.179 to 3 decimal places. So what I would say in the exam is no, because that is 17% or 17.9%. So it's less than 25%. And just write a sentence saying that yes, it's close, but it's not quite at 25%, because even rounding up to the nearest percentage, it's 18%, which is 7% lower than 25%. So just make sure you write all of the numbers in an answer that answers the question. Okay, so we have a set of simultaneous equations, and I'm just going to start off by just writing them out to give myself a bit more room, because it's a little bit too small otherwise. So I'm just copying out the question. Now, there's a list of things we need to do for these, and there are different methods. I'm just going to go through the main one. The first thing is I need to get either the x's or the y's the same coefficient. So the number before them needs to be the same, ignoring signs. Now looking at this, and I'm going to label these A and B. Looking at this, if I double A, then the x's would become the same because they both have a coefficient of 4. So what I'm going to do now is I'm just going to write 2A. So I'm going to double everything in A. So double the 2x to make 4x to make the x's the same. Double the 5 before the y, so that's 10y now. And double the 24 to make 48. Now, next, I need to probably, and it's normally the case that if I write down B again, it just makes things easier. So I'm just going to literally copy down B underneath. Okay, so next I'm going to remind myself that I'm working downwards now. So I just put little circles around these to remind me I'm going downwards. And I need to look at the sign before the letter that I've made the same coefficient. So I'm looking at the x's and I'm looking at the signs before them. If the signs are the same, we are going to subtract. If the signs are different, we're going to add. And it's that simple. Okay, now the signs are the same because they're both positive, so we are going to be subtracting. So a minus there, a minus there, and a minus there. Okay, let's start. 4x take away 4x is nothing, which is good because it needs to be nothing. 10y minus 3y. Now 2 minuses make a plus, so that's 10y plus 3y, which would be 13y. And we've got 48 plus, because the 2 minuses make a plus 4, which is going to be 52. I'm going to put my lines in. Okay, next I need to do 52 divided by 13. And we're going to do both of these divided by 13. So we've got y equals, I think it's 4, so 4 times 13 is 52. So yeah, y equals 4. Then I'm going to pick one of the equations from the question and I'm going to substitute the 4 in. I'm just going to pick the top one. So 2x plus 5 times 4, because we know that y is 4, equals 24. And again, put my lines in. So it's 2x plus 20 equals 24. Take away 20 from both sides. 2x equals 4. Divide both sides by 2. Extend my lines a little bit. And x equals 2. Now if you've got time in the exam, you can check that that's right by using the second equation. So 4 times 2 is 8. 3 times 4 is 12, and 8 take away 12 is minus 4, so we know it's correct. So x is 2 and y is 4. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got 2 decagons, and so that means they are 10-sided, and you can just count the sides if you want, but you know, if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out 1 and then double it, and then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got 2 exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. Okay, so for the first thing to do with this question is to write it out twice. Whenever you square something, you times it by itself, and itself is the bracket x minus 15. And there are multiple ways of doing the next bit. I'm going to use the grid method for this one. And we put the first bracket at the top, so x minus 15, and the other bracket down the side, which is just x minus 15 as well. And we're timesing, so x times x is x squared, x times minus 15 is minus 15x, x times minus 15 is minus 15x, and then minus 15 times minus 15 is plus 225. Okay, then these two here will add together. So when we write our answer, it's x squared minus 30x plus 225. Now the really common answer to this is people thinking it's x squared plus 225. Okay, and that is wrong. Okay, students do that, and I'll put a big cross through it. Students do that because they don't understand that you're squaring the whole bracket, you're not just squaring the things inside the bracket. Okay, so I'm asked to complete the Venn diagram, and the E at the top I like to think stands for everything. So all of those numbers need to fit somewhere in this Venn diagram. And we're going to put the square numbers on the left and the odd numbers on the right. Now there's different methods of doing this. What I like to do with this type of question is just do it one at a time. So we're going to start off with the 16. Now 16 is a square number, but it's not odd. So I'm going to leave that here. 75. Now 75 is not a square number, but it is odd. So I'm going to put that there. Now 1 is a square number and it's odd, so that's going to go in the middle. 4 is a square number, but it's not odd. 28. Now 28 is not a square number and it's not odd, so that's going to go out here. 9 is a square number and it's odd, that's going to go there. 93 is not a square number, but it is odd. And 2 is not a square number or odd, so that's going to go on the outside here. And I like to just add them up, find out how many numbers we've got in our Venn diagram. So 1, 2, 3, 4, 5, 6, 7, 8. And find out how many numbers we should have. 1, 2, 3, 4, 5, 6, 7, 8. So we haven't missed any, because it's quite easy with this type of question to miss a number out. Okay, so there's quite a few different ways you can do this question. I'm going to find out length CB, and then I'm going to, from that, find out length CE. So this question asks us for length CE. Now CE is the length that's shown at the bottom here. This is CE here. Okay, so that's the one we're trying to find. Now I'm going to first of all find out what CB is. Now what I'm going to do is just label this X. And I realise that it needs to be trigonometry, because this is a rectangle, that's a right angle. So I'll need to use trigonometry for it. So we've got opposite and we've got the hypotenuse. So we're going to use sine. So SOH. So it's going to be sine 68 equals 27 over x. And I'm going to times both sides by x and divide both sides by sine 68. So that gives me x equals 27 over sine 68. And so if I do that on the calculator, 27 over sine 68, and that gives me 29.1204. And I just do a few more decimal places than usual, because it's not an answer and you should never round your working out. If it's asking for one decimal place, I think 4 decimal places should be enough, but I'm going to try and keep it into the calculator if I can. So the next thing I need to do is work out CE. Now I'll need this angle here, which actually I can just take away 68 from 90, because it's a rectangle, the whole thing will be 90 degrees. So I'm just doing 90 take away 68, which is 22. So that's 22 degrees. Now I'm looking for this one, so CE. I'm going to call CE Y. And I've got, so what have I got? I've got the adjacent here. So this is now the adjacent. And I've got the hypotenuse, because this is opposite the right angle. So this time I'm going to be using cos. So it's CAH. So cos 22 equals equals my 29.1204 blah 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 over y. So again, I'm going to times both sides by y and divide both sides by cos 22. So y equals 29.1204 blah 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 over cos 22. Now I kept that in my calculator, so I can just press divided by cos 22. Press equals, and it's 31.4074 blah blah blah. And it says it wants the answer to one decimal place, so it's going to be 31.4. Now, if I lost you a little bit because I went quite quickly through trigonometry, this is a kind of question you do when you're quite happy with trigonometry. There's loads and loads of videos on the site that go through right from the basics of trigonometry. If you want to do these questions completely within the trigonometry triangle, then that's absolutely fine. You'll get the same answer. The easiest way to answer this question on the calculator paper is to think in terms of multipliers. Now, multipliers are a nice easy decimal you times something by to do whatever the question's asking you to do. So either increasing it by a percentage or decreasing it by a percentage. So if we ignore the second part of the question, just focus on this bit, 11% off. We always start off with 100%, always. And 11% off would have taken away 11% from that. So that's going to leave us with 89%. Now, 89% is not a multiplier yet. All you need to do is divide it by 100 to make it a decimal. So in your calculator or in your head, divide it by 100 and you get 0.89. And that's a multiplier because all we need to do is put any number in here, we times it by 0.89, and it gives us what the new number is with 11% taken off. But the difference with this question is we're not working this way, we're working this way. So if you have a look at the question, it says the sale price is 917, work out the price of the TV before the sale. So the end price is 917. So instead of timesing it by 0.89, when we're working the other way, we divide it by 0.89. Now, I show it this way round because I like to have it in the middle, but we've got to do 917 divided by 0.89. Don't do 0.89 divided by 917, otherwise it won't make sense. So on the calculator, 917 divided by 0.89 and press equals. You might get a fraction, just press S to D. And we get 1030 pounds 34. So I've rounded that to the nearest penny because the next one along, it's 337, so the 7 pushes that 3 up to a 4. And so that's going to be 1030, so 1030 pounds 34. Let's see if that makes sense. Well, it kind of makes sense that it's gone down a little bit to £917. So the actual thing makes sense. We'd expect the price before the sale to be higher than the price on the sale. Something you can do to check that it works is you can then times the answer by 0.89, and there we go, we get 917, so it completely makes sense. In this question we're asked to compare two banks, and normally when I'm asked to compare something I just put a line down the middle of the working out and I put one of them on the left hand side and one of them on the right hand side, and as long as it's identifiable which one is on the left and which one's on the right, you don't need to necessarily put the whole name down, but you can do. So I'm going to start with a super bank. It says we have 2.3% for the first year and 1.8% for all other years, and we're doing this for 2 years at £300. So first of all I want to work out what the multiplier is. Since this is the calculator paper, we use the multiplier method. So we start off with 100% always, and compound interest means we're gaining money, so we're going to go up by 2.3%, so that means we'll have 102.3%. So as a multiplier, what we do is we just divide that percentage by 100 to get it as a decimal into what we call a multiplier, 1.023. So if I times 300 by that, that will tell me what we have after year 1. So let's do that on a calculator. 300 times 1.023. And you might need to press S to D. And that is £306.90. Okay, so that's year 1, and we might as well just write year 1 somewhere. Okay, so year 2, we've got that £306.90, and we need to work out the multiplier for 1.8. So I could go through the same method as before, But actually when you start using multipliers, you realise how to just go straight there. So it's going to be 1.018. But you could do 100 plus 1.8 is 101.8 and then divide that by 100. And what's that going to be? So that equals came out a bit wrong. So what's that going to be? So 306 and times 1.018. And that says it's £312. And I'm going to round this 42. I'm going to round it to the nearest penny. Okay, so that is Superbank. That's how much we'd get. Now, the Great Bank's a bit easier because it's just going to stay at 2.2. So let's work out as a multiplier. 100% plus 2.2% equals 102.2%. And then as a multiplier, that is 1.022 by dividing it by 100. So we're going to times that £300 by 1.022. So 300 times 1.022, and I get £306.60. Then I'm going to times that again by 1.022. So times 1.022, and this time I get 313.34. Ooh, actually, that would be 5 if I'm rounding it to the nearest penny. Okay, so it says which account will give her the most money. Well, looking at that, it's going to be the Superbank. And when you're writing down an answer, make sure you write down the full name. Oh, it's not going to be the Superbank, it's going to be the Great Bank. Look at that. So Great Bank Inc. And it says by how much. So I'm going to get that by how much. Let's show the examiner what I'm doing. So I'm going to do 313.35, take away 312.42. So 313.35, take away 312.42. And I get the answer of 93p. So £0.93. Now, if you hadn't have rounded both of those, you might get a slightly different answer. And actually, technically, you shouldn't have rounded them until you got the answer. But on a question like this, where you're rounding it to the actual money she would get, they wouldn't pay her half a penny, then either answer would be correct. And in this bit here, you could have done all of this just as one bit. You could just written 300 times 1.022 times 1.022 or times 1.022 squared. That would be absolutely fine because you'll get the same answer. Okay, with this question, the first thing to realise is that we have two similar triangles here. So we've got the smaller triangle here, and we've got the bigger triangle here. And they are mathematically similar because this angle is going to be the same as this angle because they're parallel lines, those are corresponding angles. This angle is going to be the same as this angle for the same reason, and this is a shared angle. So they're two triangles with exactly the same angles, therefore they have to be mathematically similar. And mathematically similar means all the angles are the same, but we've just multiplied all the lengths by something to get to the new triangle. So, important first step of this is to draw out the two triangles. Okay, and I'm just going to sketch them out roughly. So a small one, and we've got the big one. And then copy the length. So this is going to be 23, this is going to be 9, this is going to be 36 at the bottom here, and this one's going to be 60. Okay, now ask for the value of CE, which is this bottom length here. That's the bit we're trying to find. But I'm going to ignore that, and I'm going to work out what AC is. The reason for that is if I know AC, I can take away from 60 to work out CE, because I know the total distance is 60. Okay, to do that, I need to work out what the scale factor is. And the scale factor, all you need is a length on both of the triangles, which is corresponding, which means it's the same length, but on the two different triangles.
And to do that, we do the big length. I say the same, it's not going to be the same length, but the same position on both triangles. So big length over small length. Okay, so the two I'm going to pick is obviously the bottom two, and we're going to find out what we times 9 by to get to 36. So 36 over 9, and that's obviously going to be 4. Okay, because 4 times 9 is 36. Okay, so we know we times that by 4, so the scale factor is 4. Now, if we go from big to small, we times it by 4. But here, we're going from, sorry, if we go from small to big, we times it by 4. But here we're going from big to small. So instead of times by 4, we're going to divide it by 4, because it's going to get smaller, isn't it? So we're going to do 60 divided by 4, and I should really write down what I'm doing. I'm doing AC, and that's going to be 15. So we know that it's going to be 15 here, for this bit, okay, but the total is 60, and we're looking for what's left over. So we're going to do CE equals the total 60, take away the bit we know that we don't want, and that's going to be 45. So the answer is 45. Okay, so we've got an athlete and 2 hurdles, and if he jumps the first one, the probability of him jumping the second one will change. So it's a conditional question, and we're asked what's the probability he will hit 1 hurdle. Now 1 hurdle does not mean 2 hurdles. 1 hurdle means exactly 1 hurdle, so you've got to be careful with the question. Okay, so we start here, and if he jumps the first one, then we're looking at him hitting the second one, because he has to hit a hurdle. So we're looking at him hitting the second one. If, however, he hits the first one, he can't hit the second one, otherwise we'll end up hitting 2 hurdles, and it says it will hit 1 hurdle. So he has to jump the second one. So he's either going to hit the first one or the second one. Okay, what we need to do next is work out the probabilities he will jump the first one then hit the second one. So we just get the 2 fractions and times them together. So that would be 4 over 70. No need to cancel at this point. Okay, and let's work out the probability you hit the first one and then jump the second one. So that's 3 over 7 times 10 over 13. So that's going to be 30, and then I could do this on the calculator or just do it in my head, over 91. Okay, now we're either going to end up here where he's hit the second one, or here where he's hit the first one. The word or in probability means add. So he's either going to hit the second one, or, which in probability is add, hit the first one. So on the calculator, because this is a calculator question, so it'd be 4 over 70 plus 30 over 91. So that's going to be 176 over 455, and let the calculator do the hard work there. Now, if it's a non-calculator question, generally speaking, the denominators of the fraction are a little bit simpler, and they tend to do those on the independent ones because they can manipulate the denominators a little bit more. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared
minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase. I hope you enjoyed that video. If you did, please click like, and if you really enjoyed it, please click subscribe. Also, make sure to check out our website. Our website has a lot more on it, and you can just revise anything you want. Finally, very, very good luck for those of you doing the resits in November, and I hope you get the result you want. Thank you very much.